Alrighty, here we are, back again. I'm not quite sure what I'm going to be doing today, except some optimizing that I've been thinking about for quite some time. For example, let's get right into it. I think I have some really stupid screen refreshing going on, because, more specifically, in these situations, where I have output that does not affect the board itself, and I'm refreshing the board beforehand. This is for checking if the coordinates are within bounds. And I want to check something. So if I choose easy, there's another problem there that I have to remember. So if I try to reveal anything that's out of bounds, it gives me invalid coordinates, but the state of the board did not change. I am pretty sure, however, that because of that, I don't need to refresh the board before printing the output. I can just print the output. It's not a problem because eventually it also comes back around. You read another command and we refresh the screen again. So that's that. Now, if I try to reveal -1, -1, it still works, and I try to reveal it again. This still works. Now I print some garbage, it works. I reveal 0, 0, and there you go. This type of thing is something that I did a lot here again. So I'm just going to comment it out first in case something does pop up which I didn't think of. But you know, here as well. I do need to do that. Do I need to refresh the screen here? I do. And here I don't. All of those places I was refreshing the screen when in reality, or at least apparently, I didn't need to. Let's see, what did I change? So cell is already revealed, so reveal 0, 0, and I got that, but if I do it again, all I have to do is print the line because the state of the board was not changed. I mean, refreshing the board when nothing new happened is just useless. So that was low-hanging fruit. Another thing that is really stupid, actually, before even that, about the MineCweeper, I realized something in the meantime, that this is a really stupid way of doing it, because even if make fails, I'm still going to execute the program, and if I do execute the program, I'm just going to execute a outdated program. What I can do is this. This is a command line thing. It means that if make fails, it's literally a Boolean operator. Both have to evaluate to true in order for this to work, or I guess more correctly, the first one needs to be true in order for the second one to execute. If make fails, we're not going to execute an updated program. Yeah, I started editing the previous parts finally, which is why I'm even doing this video. It brought about many problems. Another thing, for example, which is kind of stupid, is this block. When I write quit, what I do is break. What happens if I break is that I just go into the rest of the code. In other words, if I come here and write quit, I get this. Invalid coordinates. I love it. Like, I am such a good programmer. I take all of these cases into consideration very clearly. So the fun thing about this is that we have not allocated anything at this point, which means I can, instead of just having, you know, some go-to to the end of the main to like reveal stuff, I can literally just come here and instead of breaking, we return 0. We just break out of the main. So if I write quit, it actually quits the game. Wow, who would have thought I would have failed that? Is there anything else here that I remember? Not really. I never checked how scanf would work here if I gave it a string, so let me do that now. If I do this... Okay, so it always takes the first character. That's a bit annoying. Okay, what if I instead take in a string, and this has to become a sharp pointer, which means I may as well just use the buffer again. What happened is that because the first character was an E, it ignored all of the garbage and gave me the easy board. What I'd like to do is to not allow all of that garbage, so I think I may as well just directly compare the buffer. String compare it. Again, can I switch on strings? And I'm going to just return 0 here as well. I don't want the rest of the main to execute. If I put the buffer in here, case, can I do this? Is what I'm wondering. E, printf, E, break, and default, well, break, why not? So I can just, whoop. So, moon. Oh, it has to always be an integer, okay, fair enough. If string compare of buff with E equals 0, what I do is we set this stuff. Okay, we are going to say that else you're going to just continue, may as well just continue. If you fall into any of these, you actually just keep going. Yeah, I suppose I can just like break here. The else falls into the continue. So. Okay. What do you give me? What the fuck? Here we go. So if I write nothing, that doesn't work. If I write E, it does work. Alright, that seems to be good, which means I can just do that. Right, I have this pattern a lot, where with an X and a Y I want to get the board's cells at those indexes, and what I'm thinking is that I could probably make a macro out of that. So I'm going to define it here and then move it up. Define mat at, I think it's the convention. So we have boards, X and Y, and could I call it cells at, mat at, cells at? I mean, it is just, again, it's just meant to be for the game. It's not like this is going to be used as a library. So I think cells at is actually a good name. The thing is, I am pretty sure I use this pattern with pointers as well, which makes this a bit more annoying. Exactly. I use it with pointers and with, well, direct access. If you look at what I'm doing here, you'll notice that here, because board is not a pointer, it's the board itself, it's on the stack, I use a dot instead of an arrow. So what I think I'm going to have to do is, in these situations, I'm going to pass it in as the address. Anyway, I'm going to say board of cells on index y times board width plus x. Plus, okay. I think that should be it. If it doesn't work, whoop. Do I even have any assert right now? I don't. I'm going to delete the header for now. If I need it again, I'll just bring it back. So here we have a macro. They are very useful. For example, here, I do exactly what that thing is meant to do. So I can just replace with cells at, and then give it the board. It's a pointer, so I don't have a problem, X and Y, and no problems. What is this? Is the init board. So if this, I'm still returning, give me a second. Here we are. Moon. There you go, it still works. So it just makes it a tad bit more readable. If you look at this, it's way more readable than all of that gibberish. Here as well. So passing the board, the X and the Y. That is the order, right? X and Y. Okay. Do you still work? No. The reason why I passed in as a pointer was exactly to avoid that. Invalid type argument have board, okay. An expansion of macro to 53. Alright, why? Oh, I did it on every one of them except here. This is why you wrap stuff in parentheses. It was trying to access before getting the address. There you go. I can choose medium and still stuff should still work. Did I happen to... No. Now it begs the question, is it the changes that I just did? Or was there something different that I forgot to change back? This would be reveal cell. How? What? Huh? Where's Prince? Yeah, you. If cell is revealed... Uh-huh. I just don't really understand why. Could it be init board? So how many mines are there? Replace hashtag with hashtag. 40 substitution, which is what I wanted. It's correct, number of mines. So board cells is that. For each of those we do this. We set it to true. Do you think this is not working? Is there something about the macro? That's really peculiar. It looks like it didn't initialize properly. If I reveal 0, 0, it does it again. What is happening for some reason is that no cells around the mines apparently have the mine number greater than 0. Well, here we go. Okay, what do I want here? Maybe stop on 28. So with medium, why not? Looks fine. Okay. Looks fine, I guess. Next. So you should be fine for a little while. Why is that always returning true? Oh, I'm a fucking moron. I'm a fucking moron, bitch. Oh my god. How did the compiler... Oh, yeah, that's why. The problem, I am not using the right x and y here. The compiler didn't warn me that I wasn't using these variables because I used them in here. This is meant to be an x and y, and x and y. Why did I close that? Very fun stuff. There you go. It's working. So we got that into a macro, which makes things slightly better. We don't need all of these characters. Hell, we barely need more than 64 really, but whatever. I did not come up with anything better for this. Can I come up with anything better than this? Could make it an attribute of board, but then that implies passing board to some other functions which don't need the board otherwise. Oh, right, in here. A funny thing about this is, while I was editing the video, is that I noticed I had another if here. So after this print cell method, I had basically another if here to print the vertical bar after the board. So this bar here I was going to print with another if, kind of like that, and I realized that, oh, I could just print it here. I somehow didn't realize that I could do the same logic here and just print that here. Sorry, that here, because it's always on the first iteration, so I may as well just do it before we iterate, so yippee. Anyway, let's make sure it works. Yeah, it works fine. So I believe I can remove these. Haven't seen any problem yet. So stuff like this does need the refresh screen, so that's fine. Also, I'm going to pass in buff plus 1 here, because doing buff plus 1 here is really weird. So that's that. I think about now is the time where I can do a thing that kind of really made me do this at all, and that is optimizing the cell struct. Space-wise, the cell struct right now is 3 bytes for booleans, plus 8 bytes for a mine number. It's not like it matters for a program like this, but I see that it's opportunity for optimizing, which I just want to do for the sake of it, even if only for practice or something like that. I think anyone can agree that one whole byte to tell you whether something is true or not is such overkill. Because we have 1, 2, 3, 4, 1, 2, 3, 4. We have 3 of these, and then we have 1, 2, 3, 4, 5, 6, 7 for the mine number. It's a lot of bytes, especially when these are literally just going to change this. These 3. All it changes is the first bit. It's all we really care about. In other words, if we look at a single byte, we need 3 booleans. So let's imagine that these can be booleans. Maybe I'll even call them booleans. So revealed, flagged, and mine. These are our booleans. Let's imagine we can put them into those bits, right? Because they're either true or false, they're 0 or 1, they can stay in a single bit. The mine number goes up to 8. 8, and it includes 0, so that's technically 9 numbers, which means that unfortunately I can't just put it in 3 bits. I will need 4 bits. I don't even know how to represent these. That's exactly it. We can treat this as the mine number, because you can represent all of the numbers in here. So if this is greater than 8, womp, something went wrong, and this bit is just a free bit. We are that efficient. In a single byte, we're going to have a free bit. We are efficient as. What that means is that I would actually want not all of this stuff. I would want to probably do something really interesting. I've never done this before, by the way, this type of optimizing, which is type def a uint 8 into cell. So I no longer want this, I want this. Don't do that. I want that. That's going to be fun. Now, where are you from? Oh god, uint 8 type. Include standard int. So standard int. And there you go. How do we start this? Let me ask the compiler for help. Okay. So now we don't have any of those attributes. That means that if we want to check whether something is revealed, we're going to have to do bit masking. And if you remember, I think it was like in part 1, I said something along the lines of bit masking is a pain in the ass, and that still holds true. So how do we check if something is a mine? I should have kept that scheme around. How did we have the cell before? Here we are. Okay, so we're going to say, I'm going to keep it the same order. This is unused, and these are the bits, the mine number. So that's going to be how the cell looks like internally. In other words, I fit, what was it, 13? 13, 11, right? Because this is 8 bytes, 9, 10, 11, because of padding 16. This is 16 bytes. This will be a single byte. Yay, what the f— To get the flagged thing, we're going to be using, to get each bit, we're going to be using macros again. Is mine. I'm going to take in, we're taking the pointer, or what would make more sense here? Let me look at the errors even. Here we have a pointer. So here we have the cell directly, and we want to get the mine number. And here we have pointers. Oh, that's not a problem actually. So I'm likely to always have the cell and not a pointer to the cell. This is because, well, once I index into the board cells, we don't have the address, we have the cell itself. And if you are thinking about the print cell method, which takes in the cell pointer, the only reason why I took in the cell pointer instead of the coordinates, mind you, is because it was just more efficient in terms of memory. This is 8 bytes, where then passing in the coordinates would have been 16, I believe. Because our cell is going to be a single byte now, all I have to do is pass in a copy of the cell. It's a single byte. It's more efficient this way. We are assuming we always have the cell itself. We are going to say that to know if it's a mine, we need this bit. What's the best way to do this? This is 2. What I'm saying here is that this is in hexadecimal, this would be 20 or something like that. So I guess I can do that. What I would do is I would end the cell with this. And it will be something similar for is flagged, because flagged is this bit, which means that this is 4. So I can just come here. I don't know why I put an F here. I can change this to 4, that to 0. And to know whether it's revealed, instead of 4, it's the last bit of them all, which means that is 16, which is A. Wait, is A 16 or 15? A is 15. Wait, no, what am I saying? F, right? Am I tripping? 1, 2, 4, this is 8. Am I stupid? I may be stupid, so I'll change this to 8. Now, again, it's the first time that I'm doing this. I may be completely wrong, but this looks right to me. And that's what matters. So, in case you haven't noticed, we are passing the cell like this, which means that in scenarios like this, what I'm going to do is stick this macro in this macro. And I'm hoping that the expansion of the macros and whatnot does not cause any problem. That seems good, though. So that's to know the cell. To know the mine number of a cell, what I would want to do here is get the cell and that with 15. That should be it. You know, I thought I would have to have some bit shifting, but yeah, I see. Yeah, fair enough. I'm being a bit silly here. Because what this is returning would be, assuming like it's set, we would return this. Which would work because it's not 0, but I think it'd be a bit better if I like shift this. 1, 2, 3, 4, 5. Let's shift this by 5. Can I record a macro for this? I just want to record a macro for this. So find and, change inner scope, add these, move back, escape, paste, move forward, append, upward, select to the end, yank, down, paste, increment, down, beginning. See, it works. Oh my god, such overkill. Do I need to do that here? I don't need to do that here. Okay, that was such overkill. Do you think I can do it here, for example? So if I just... There you go, it works. Yeah, efficiency, boy. I don't even know if this is correct. I mean, I think that's it. Okay, it seems to be fine. Okay. That is working as intended. I'm actually going to keep this around, because these are basically getters, I also need setters. Hashtag define set is mine, or just set mine. I'm going to put them after actually. Cell. And what are you going to do? You are going to get the cell and or equals that. Set flagged would now be, instead of that, it would be that, and set revealed would be that. Except there are things that I want to toggle, such as the flag. Maybe I will also pass in the bit, I guess. I don't know what to call this. And I'm going to do this in a bit of a different way, because I'm going to clear it and then or equal. So I'm gonna get basically this, and I'm getting this specific bit, right? Getting the specific bit. I actually don't know how this works in C or any other language really. If I come here and I set it to 0 like I said, can I then like or equals this to the bit? Set mine. So I'm figuring this out in real time here. Does it even compile? Standard tool. Required. Yeah, I thought so. I thought so. Do you think it would work like that? No, I would want to XOR it. Right? No, I wouldn't. I want to toggle it. God, this is weird. Oh, I deleted it. No, it's right here. Oh. Why end? Why am I doing end? Right. I mean, okay, that's the rough idea, I guess. So we get the cell, we basically mask it with the correct bits. So if this is for flag, I want to mask it here. And I think it would be easier with 8 to 11, which is B, I believe. And then we OR that with the bit, shift it over by the right amount. Like, I understand what's going on, I just really don't like it. So, wait, why did it go from B to D? Did I? No, it makes sense. So if I want that one, that would be 7 actually. What this is doing is it's giving me the whole mask without the bit of the thing that I'm changing. So if I'm changing the revealed bit, All of this is the same, except the bit will always be 0 here. Now, if I OR that with the bit that I set, shift it over to the right cell, it should be enough. I feel like I am severely overcomplicating this. Is there an operator that does this? Like, as far as I can tell, this works. Not pretty, but it does work. Anyway, what I also realized is this is really stupid, because I could just shift it over first and then end with 1. Makes this slightly better. I don't like this. Yeah, it's what I did. Interesting. It's basically what I did. I don't like it, but it'll do, I suppose. Let's try it. Alright, now I can start actually refactoring stuff. In init board, request from member is mine is something that is not a structure or union. So now on line 47, we are trying to get .is mine, but we don't have that. What we do have is we can come here and do is mine, and there you go. Let me see if that list works. It no longer complains about line 47, so it may work. Line 48 is the same deal, where we have this, but in reality, what we want is mine of this. Wait, oh, this is not checking, this is setting it to true. So I actually don't want this. I want to set mine here to be true. Yep. Okay, this is totally not confusing. So cells at, I didn't get a way to set the mine number, but I think if I just, I don't know how that works. I can directly increment it, I think. Let me see if it complains about that. Okay, it's not complaining. So then maybe fine. What else is revealed? We are setting is revealed to false. So set revealed of this to be false. Okay, we are making. Is that a good thing? I don't know. No, it's not a good thing. So reveal. We revealed. If it's mine, so we reveal the cell. Let's go there. We set it to be revealed. We reveal it. If my number is 0, I think I forgot that. Okay. It seems to have worked. Very nice. Can I unflag stuff? Again. Wow. The bit stuff is working, apparently. How do you... Can you disambiguate it? I don't think you can, actually. Yeah, that has to do with the way the bombs are placed. Stuff like this is not checked for. It's a 50-50. One of these is flagged, the other isn't. I hit the bomb. Fuck me. At least I don't think there was any way around it. So, that works. Yeah, I'm going to assume it works. I can't really be bothered to play another game now. If we're curious about what I meant of the size, it's 1. That cell struct, which was because of padding 16 bytes, has become 1 byte. I also, fixed this loop not actually working. I got rid of some useless refresh screens. Straight up changed how the cell works, and I don't know what to do anymore. I actually remembered something really quick that I can do in init board. You see all of this loop? This is indexing into memory, which was malloced, but never initialized. What that means is that there may be trash in that malloc memory. Not likely, given it's the first malloc we do in the program, but still, there can be trash, and I'm just messing with it as if it's nothing. In reality, I am initializing the board here. Another thing that I can do, which honestly just makes even more sense, is instead of iterating through that, I'm going to memset this. Actually, even better would be to use calloc, because calloc, what it does is it automatically sets stuff to 0. The memory is set to 0, so I may as well use calloc. It's the same as malloc, but it initializes the memory, so it's these many members with these size each. Okay, fairly simple. At least now the memory is initialized to 0, which is, by the way, all that I would need to do because we are working with booleans. I actually thought it at the time, but the loop that I had here before, setting each cells is revealed attribute to false, that was useless, because it was presumably already set to 0. I think that's it, because it's revealed, flagged, mine, and I set the mine to true in this loop, so it's not a problem. Kind of simplified the code a little, I suppose. This is allocating the space and initializing, this is just setting the mines. A thing I thought of in the meantime is to change these things a little so they're a bit more intuitive, and also put stuff like this into macros. I know, a lot of macros, but mine offset and then make it 0x5. That way, if I want to change where it is, I just change that constant, and I get to use it down here once I change that a little. Flag offset, and this is revealed offset, and this is so now we just align them because it looks nicer this way, and here we change to flag offset and to reveal offset. Mine mask, I guess. Hashtag define mine mask to be this. This is mine mask. Yeah, it looks fine. I wanted to change it so it's a bit more intuitive what is going on here, and it's really just coming down to this part where I would do something like, so df is a, b, c, d is 13, which is 1, 1, 0, 1. Then we have 1, 1, 1, 1. This is the 5th. What I can do is change this so it's 1 left shifted by mine offset and negate that. I think that works. For the sake of consistency, keep it hexa. I think that does the same thing. I'm going to test it out. If it doesn't, whoop. So the idea is that I'm not x1 left shift, and here it's not mine, it's flag offset. Here is a similar deal. Alright, I think this should do the same thing. Good. Compiled, easy, reveal 0, flag 3.1, reveal 3.0, seems fine. I mean, it seems to be working. Let me try something like reflagging this, seems to be toggling just fine, which is good. It set it as a mine, it's printing correctly, mine mask, yeah. As far as I can tell, stuff is working. You know, it's a fairly interesting thing. Again, I really like the fact that I got a struct that was with padding 16 bytes and reduced it down to 1 byte. And it has all of the info that I need and 1 extra bit. Yeah, I quite like that. It resulted in a lot of masking, offsets of bit manipulation that looks honestly really jank. I may look into whether or not this is the best way to do it. I'm actually kind of curious now. How do I preprocess only? Yes. And output that into main preprocessed.c. It's pretty interesting seeing all of that, but this is not what I care about. I want to see the macro expansions. Oh my god. And this works. That's the best part about it. It works. How many characters is this? 194 characters. A thing that I can do now that does not relate to optimizing the program anymore, if anything it's probably worse, is giving it some color. And it's a thing that I've teased on part 2's thumbnail. You can actually give these boards color. So instead of just being white on this bluish background, I can actually make it have the colors that MineCweeper has. So if you look at like MineCweeper, let's go to the images, why not? And you look at an example. I don't know if you have all of these colors, but you can see that numbers of specific numbers have specific colors. 7 is like that orange, 5 is red. Well, that depends on the MineCweeper variant, but you get the idea. And I'm wondering if I can do that. So I would need 8 colors, 1 to 8. And then red for that. What's a mine look like? It's straight up black. I could make it like the symbol be white on the black background. And in case you're wondering, we are bringing back the ANSI codes. That is how you can do it, because there is a section here for colors. And you have the colors here, here, and this little table, which is actually a picture. Set foreground, set background. I don't know how this works. Also, I'll have to remember that this terminal is in Vim, and I think it may have different colors to the actual terminal. Like MineCweeper. It may not look like it at first, maybe, perhaps, I don't know. But I think it can display colors differently. I'll have to remember that. I would want to do it according to the actual shell, not according to the Vim shell. So what's up with these numbers, 38.5 and 48.5? Are they just, you just accept they exist and move on? Okay, I suppose you just accept it. I suppose we would do it here. If it's not 0, we will now switch on the mine number. So switch on mine number of cell case 1, and actually I may as well do a macro. Let me go to the beginning of the thing, record on here, we just yank, paste, forward, increment, back to the beginning, stop. 4, 5, 6, 7, 8. Okay. I'm going to bring back assert because that's a good place to put it. We should never reach there. Program will end anyway, so I don't do anything after that. Just make sure we have a break here. We basically want to do this, and depending on the style, which I can print individually here, we just do that. Yeah. Well, first I need a color scheme, I suppose. Super, maybe colors? Oh, how nice. What do we have? We have bright blue, green, red. I was thinking of red for the mines. I guess I can make it a background. Give it a background color as well. Oh, and I may have to undo this in order to have different colors and stuff. Palms could be like black on a white background or vice versa. This could probably just be a blank cell. Gray. 7 is black, that's weird. Suppose I could put the numbers in like a gray background, and then the color be on the... because you can set the background and the font. Yeah, background, foreground and background. So let me just get one of these. Maybe I should just, since I'm printing that anyway, event 8. Print, oh my god. I was playing around with Python, and now I'm doing that instead of the Chad's printf. Anyway, we are going to printf, and here I may as well... no. I'm going to print the x1b, I think, so 38.5, and what was it? It's like this brighter blue. Do you think, because this is a bit different, there are these colors as well. And these have the normal and the bright variant, so maybe these are enough colors to represent. I don't need that necessarily, maybe. Let's try a bright blue. I guess we just print the thing, right? So let's try a bright blue, which is 94, over a gray background. I guess bright something background. Bright black, 100. Now, in somewhere, probably at the end of all of this, I probably want to do this regardless because of the borders. There's a code to clear. Reset all modes. Oh yeah, there's also bold and stuff. Maybe we can even use that. It's escape 0M. make. Okay, I forgot that. This statement may fall through, I'm well aware. It's going to be a bit awkward to see if it's working, but oof, there's also something with the spaces. Oh yeah, it has to do with the fact that we're not printing these numbers. I want, yes. No, they're meant to be here. Why are they not here? Oh, my dumbass is still not printing the thing. Oh, I am. That's interesting. You think I used the wrong code? Oh, is it supposed to end in M? It is. I forgot the M. Make MineCweeper easy 000. Okay, we have colors. It's not the prettiest thing. I thought I chose bright. Right, it's what I was saying. Vim has different colors in the normal shell, so I have to use it like that. This is a bit better for colors. Alright, so that can work. And we need a break here, because now we're going to be doing this basically everywhere. Make MineCweeper easy reveal, that's 04, I think. It's there. You can see it's there. Because of the spacing, the number is not centered, which is annoying, but honestly, I don't know what to do about it. Presumably, you've just watched a quick, very sped up segment of me editing the colors into the MineCweeper board. Since nothing really interesting happened there, I just put it into a time lapse. You didn't really lose anything, it's just me looking at the colors, changing a thing, having a new idea that's not really working out. Not really working, so I just go do something else. Because at the end, I do just move on to the next topic. I don't really like show off the board. I thought I'd do it now. I'll slot this into the video. There's not much to go over. It's just colors on the board. First things first, let me just blow up a mine so I can show off everything. This will have like mild spoilers for what's after in the video, but it's nothing crazy. Here we go. Picking an easy board, the first thing you can notice is that the board itself is now gray and the border is black. I thought I would do it because why not? I did like try having like the numbers also be kind of highlighted, but that ended up looking weird here on the edges and whatever, so I just didn't do it. If I just blow up a bomb here, you can see that, well, now a revealed cell is just white. It's at least brighter than the other, which is the idea. It's meant to have this contrast and whatever. Next thing, the numbers are now colored. They're according to the colors that that little image that is in the video. If you just rewind, the little image that I used, that I based myself off of, is right there. So the numbers correspond as closely as I could to that. A flagged cell looks like this. It still keeps the dark background. It just has exclamation mark to be read now. Oh, that's interesting. Well, quick bug fix. I was not expecting to do this. Okay. Well, I was not expecting to be bug fixing now, but in case you didn't notice, I have this flagged cell, it's 0, 0, and this cell has 0 bombs next to it. What happened is that it belongs to this group of cells that also have 0 bombs around them. And what happened is that during the recursion, I never check if a cell is flagged. So what ends up happening is that if I reveal any other cell in this group of 0 mined cells, it will recursively reveal all of the other ones, including the flagged one. We don't want that to happen because the player presumed that was a bomb. We shouldn't be really saying, no, that wasn't a bomb. Yeah, I'm surprised I didn't notice that earlier. Where do I go? It's reveal. Here we are. If it's revealed, we continue. Or if it's mine. So just, where's the thing? Is mine. Or is mine. And I give it the cells at. The cells at, what are you taking? You're taking the boards, the new X, and the new Y. Right. I think that's what I have to do. I think it's here too. You don't have to check here because when you call the method, you check beforehand that the cell was not flagged. That should be it. I got the wrong flag. It's not his mine, it's his flag. So if it's a flagged cell, regardless of whether or not it is actually a mine, we don't want to reveal it if it's been flagged because that's what the player assumed. You can just moon it does that. If we go to easy, and then let me make sure I don't fall into anything. So I want to flag, let me zoom in. I want to flag this boy, which is like probably here, 3, 0. Then let me reveal 4, 0. There you go. Despite the fact that 3, 0 is not a bomb, it did not get revealed because it was flagged. That's how you want it. Now, let me also make sure that everything else is fine. I can reveal that. So what happens? Okay, you don't win. That's what I wanted to check. So we're not winning because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 mines. That one is not a mine. I was doing this on purpose. Okay, I just wanted to make sure that the win condition was not messed up. Okay, so that was a quick troubleshooting. Fixed revealing cells recursively on a flagged 0 mine. That's not a 0. 0 mined cell. Updated MineCweeper. So ended up doing more than I expected. This was all just to say that it has these colors now. You will see this through the rest of the video, but I thought I'd just show it off a bit better here, and I ended up finding a bug, which is always nice. Well, not really, but we fixed the bug, which is nice. Yeah, that's it. Enjoy the rest of the video. It's very fun. If you want to know exactly how I used the colors and how I did anything, like how do I have the border specifically a different color, you can go into the description. There's a link to the GitHub where you can just check out all of the code. It's all there, everything that I made. Okay, I'm gonna work on maybe getting a loop on the game in the meantime. If we lose the game, maybe have like a section where can I what? Because I'm thinking we do malloc the board, the cells array, and we would have to make sure we either free it and then allocate again, or just reallocate it, depending on size. Both are viable. Also, right, I mentioned a lot in previous parts, in one of the previous parts, where that I would factor out this code into a separate function, and I've come to the conclusion that no, I'm not. That's annoying, because this works off of being in the main loop. I've already talked about this, but it works off of being in the main loop, so I can break and continue on it. If it's in a separate function, there's no loop in that function, so I can break or continue, which means that I would need like some special return types in order for the main to then act accordingly. I'm not going to be doing that. I just need to get a game over screen now, which I may as well just do it like here. So printf, try again, and then like read command to the buffer, and I'm going to just have it be yes or no. If string compare buffer with, I may as well preemptively do this. Also, yes, I am putting it at the bottom of the main. If it is a y, aka yes, I'm going to do something. Else if string compare buffer with n, we're going to do something else. I'm not going to put the else. We're just going to break out of this. Else we are going to, yeah, we have to init the board. So what I'm going to do is always free the cells here. And if we get the yes, what I'm going to do is use the forbidden goto. This is going to be begin. Game. Right. The reason why I'm freeing first is because in allocate, in init board, sorry, we allocate the board. I could just replace this with realloc, which takes in a few extra parameters, but I just don't want to, and there's nothing you can do about it. Quick test. Oh, but it's the same board, isn't it? No, it's not. No, it's not. But matter of fact, take a picture. Yeah, it's not the same board. Nice. Try again. And then I want to move the cursor up, actually. 2 cells? No, one row. I don't know why I said cells. Move cursor up, 1 cell. 1. Oof. Right, whatever. I'll deal with that. What did I change exactly? Try again, yes, no. Why is there a tab here? Why is there a tab? Oh, right. Forgot about that. Want F. Yeah, not bad. So when I write quit, I would want to do something. Okay, I am going to do the thing. I'm going to realloc instead of calloc, just so I can have it after, because now I want to check where's the quit. The reason why I don't just return here is because memory leaks. It's not like it matters, it's the end of the game anyway, but it's the end of the game anyway. It's not like the memory leak is going to cause a problem. But, you know, good style, I guess. And now I want to go up. I want to go to init board. I don't want to calloc, I want to realloc. How do you work? Give it the pointer and then size. Size bytes, okay. So I have to pass in... This is like that again. And I have to pass in board cells. I'm hoping that's it. This basically allows me, if I need to allocate a bigger board, it'll work. If I need to allocate the same size, it'll probably return the same thing, probably. If I need to return a smaller size, it'll probably return the same thing again, but it'll free the remaining bytes. And I have to set this back to 0. So, good thing I noticed that, because otherwise it's an instant win, technically. This could also be called init game, I guess. So if I go easy and I'm playing and I reveal that, oh no, I lost, and then I press yes, I go to hard, and it's still revealed. Alright. Oh yeah, I need to... Now it is an actual danger of having trash on the board. So now I do need, in fact, to memset this. Memset takes in the pointer, the character to which to fill, so board cells. Fill with 0, how many bytes? Board with, pardon me, board height. Do I need to multiply by size of cell? Now it's not a problem because size of cell is 1 byte. Okay. Again, we're going to the easy. Oh no, we revealed the bomb, or we won, or whatever. I want to play again. I want to go to now a medium board, and now it's a medium board. I reveal 0.15. Oh no, I lost. Let's try again. Let's go back to an easy board. I lost again. I suck at this game. Let's go try the hard mode because I'm clearly up for that. And would you look at that? I lost again. I rage quit, and there you go. Very rudimentary, but it works. That's what this is all about. Yeah, does it barely work? Yes, then it's fine. That's how software is made nowadays anyway. Hello there. As a little, I guess, footnote at the end, I've remembered all of a sudden that there is a problem with the logic. There is a memory leak, as a matter of fact, and it has to do with this loop. And if you're paying attention, you probably understand it's right here. The problem is that when we come around to begin game, after we completed or lost the game, whatever, we are in the retry stage. If we answer yes, go to begin game and then quit, we are returning without freeing the board's cells, like we do down here. To get around that, I am just going to get, I'm not even zoomed in, just going to get the free cells and stick them in here. Yeah, so moon. Basically what was happening is that if I hit a mine, I lost the game, I would press yes, and then if I wrote quit, previously I would just return 0 from the program, I would end the program. Now I actually free the cells beforehand. As a matter of fact, that brings more problems. Well, not really. So what I was thinking is that because we do reuse the board, maybe I shouldn't do this. Because we do reuse the board and we free the cells here, I was thinking it would be a problem once we reallocate it, but when realloc, if I go to, what is it's in its game, realloc, I am pretty sure if you provide in nothing or a freed pointer, it will still work. Maybe it won't actually. Let me see something. Okay, yes. Okay. I mean, seems to be working. Seems to be working, but I don't know how. I don't know how it's actually looking under the hood. Because realloc does work like malloc, but only if the pointer is null. And the pointer, when we pass it in, is not null, it's just an old pointer to the heap. Which is also, yeah, it's not desirable. Okay, I'm going to do something else. When we find this, we go to exit game, which is at the bottom, and what I'm going to do is if board.cells is not null, I'm going to stick this in here, right? That way it's a bit more, not only does it make more sense here, you know, if you press quit, you go to the quit area of the code. That way I also don't have to worry about it. So in theory, I can write quit, no double pointer exception, double pointer free exception. I actually don't remember what it's called now, but I can still, you know, come in here, say I want to try another board, and stuff should be fine. Okay, yeah, that's it. I just happened to remember that, and yeah. Hello again. Another little note is that I remembered that free does not need to check if the pointer is null, which means that if on the first screen we do write quit, there's no problem in freeing or trying to free the board. The board will be set to 0 because of the way we initialize it. The board at this point has been 0 initialized, which means that the address of the board's cells is technically 0, which is the same as null, which means that going to exit game, we are technically we're quote-unquote freeing the null pointer address. We're freeing the null address, I guess, which means that we should be able to just free regardless. So if I moon and then I write quit, we don't crash. And yeah, that should be it. So yeah, that was it. Another footnote, but that's all I wanted to say. Bye.